I recently purchased this Quorn Cutter Grinder from eBay, and it was inexpensive, but as you can see from the condition, it was rusty and in a very poor state. The engravings on the dials were far from clear, and apart from being obscured by rust, were in some places more deeply indented than in others, and I felt I could do a better job. The two main bars that that set out the accuracy of the machine at the front and the rear on the bottom were pitted with rust, and I felt the best thing to do was to replace these with stainless steel, which was a fairly simple job. The only thing is that the rear one was secured with Loctite, and that required application of heat to be able to unglue it. The vertical column hadn't got the spiral groove in it, which it should have had. All of the ball handles were painted black, and some were rusty underneath the black. I spent a bit of time cleaning those up, but they were quite nicely made underneath all that. A number of the pivots of various functions were a bit sloppy, and I remade them. There was no collet holder no collet in the collet holder of the main spindle, so I replaced that with an ER spindle, and we'll show you that later. It came with one stone only, and I had a bit of a job getting that to run true, and made up a number of others with diamond cutting wheels. But apart from that, it all was obviously going to work, and I set to. The whole thing is complete. It's obviously amateur made, as they all were. The standard of machining is average, but the dials are not very good, so I'm going to redo the dials. That'll be easy to do. So it was very rusty. I've cleaned some of the rust off, and that should make an interesting job to do. I've made good progress now with the Quorn Cutter Grinder, and I've now got hold of a book which Professor Chaddock wrote on how to make all the various parts, and there's some very helpful drawings and hints on how to make it, and it is a very useful bit at the back particularly that shows how it's used and various things that can be done with it. It's a very versatile tool. So yeah, a very good book. So that gets me started. Now I've taken everything off the machine that as I found it. It was very rusty in places. I've scraped off and wire brushed off all of the rust, and everything's now clean, and I've started work on making up missing parts. Now this is the smaller of the two holders. This one in the book he calls the spiraling head, and it had no shaft in it. It was just empty, just a hole drilled through, and these bits had been made. I've subsequently made up these parts, and the ball handles on the whole machine were all painted black, which is a terrible shame because they're quite nicely made and are quite a nice feature of the machine. So I've stripped them all, and I will do on the whole machine now. So this is a hole that was previously made through here, through the casting, and unfortunately it was shaped bell mouth, so it was tight in the middle and loose at the ends. So when the shaft was in, it rocked about. So I've let in 2 hard steel bushes at each end and super glued them in. They're run in 10 millimeters. I made sure they were a nice sliding fit on the shaft that I'd made up, and that now is very snug. I'll show you that in a moment. This is the shaft that I'm using, which is a ER16. You can see that. Leave it this way up. ER16 C10. It's that length as it's applied, 100 millimeters long, and that diameter. And what I've done is sleeved it with steel, which I then carefully turned down with a centre in this end and this end in my accurate chuck. So that then enables me to get this to run nice and true, which is essential. Then this slots in here. That's a nice sliding fit, and there's no rock or clicking noise or anything when it's in there. It's just a very good fit. And then on each side, that's a stop that goes on this side. Oops. Right, I'm just fitting this. This is the thread follower, I suppose you'd call it. It's a pointed. I'm not quite happy with this. This is a pointed end that fits into the threads on here. So we just put that in. Just loosen that off a bit. And that has a cone on the inside that fits into there, and I made up a threaded stop at the end. So this is free to move, and this sits here as a stop. It can go anywhere really. I'll put it there. And that stop fits, that thread follower fits in there, and the action is that runs down until it reaches the stop at the end. Now there's 2 problems with this. You can see that that's rocking from side to side. So this needs something more positive in there, and ideally it really wants a matching thread on this piece here. to think about how I deal with that. But anyway, this is done according to the drawings. Then there's a stop on the top in brass, so you can lock it in any position, and then there's a lock at the bottom. So that is it complete. And as in the book, but except it didn't use an ER collet, but that's much easier to use, and they're now available as shafts. And if you're lucky, doing this from scratch, you could ball that out so it fitted a standard shaft. But yes, that's I'm pleased with that. That's part of it done. Now the main fixture that takes cutting grinding, I fit an ER20 collet chuck, which is with a rather tighter nut than you normally find. That's just gives a little bit tighter access to the grinding wheel, which I think might be helpful. This is the graduations as they are when I bought it, and you can see the first section of it is quite faint. It gets increasingly deeper until you reach this point here when it's really mowed right into it. So the numbers are virtually indistinguishable. You can't see them, and they're also not numbered in the way that it says in the book. So I'm going to have to redo all the graduations, and where this plate index is, that should be stiff and there shouldn't be any slop in it. So that little pin you pull out so you can index in these holes any number, any combination of 12. So you can have 3 or 4 flutes. And if you're lucky, you hit one that's fairly stiff, like that one, or you hit one that's it. That's not too bad, but it still shouldn't have any shake in it at all. Yeah, it's just, I can do a lot better than that. So I'm going to drill each of these. Just take that out so you can see how it's made up. I'm going to drill each of these out to a larger size and bush them, and then re-drill them. So that's the plan, and that's the little pin that indexes in. And this particular ER collet is yes, 20mm arbor, and the hole that's through here is 25. So this is a sleeve 25mm, or just a little bit over 25mm, that fits very snugly in here, so that when it's tightened up it grabs hold of it quite nicely. It doesn't have to be rammed on. You can get an ER32 collet chuck in here with a spindle that's 25mm, so I've ordered one. It has to come from China. I'll wait until that arrives. But in the meanwhile, I've got all the parts that I need to get this working and test the machine. But my next job is to drill these out and fill them with plugs, and then I've got that so that I should be able to drill those so that they fit properly this time. I like this arrangement. I like this a lot. This is not how I would have chosen to do it, but it's very neat. So it's a tapered collet sleeve, I suppose you call it. And when you tighten this up, it squeezes onto that collet and nips it on. It's nice, I like that. So I've got to take these off and re-engrave them. And no problem to do 360-degree divisions. So 360 divisions is quite difficult with a lot of people, but I've luckily got two ways I can do it. I can either do it on a spindexer. This is the index ring, which I've now drilled and plugged all the holes, so I can now drill fresh holes, and I'll mark this out with layout blue, and I'll use the pin here to scribe the position of the pin all the way around in a circle, and make sure that when I do the dividing using my division plate that it comes out in the same spot on each one. Unfortunately, when this was made by the person who did it originally, these holes were drilled all over the place. It was not on centre when it was chucked up, so that they gradually came to one side further out when they were drilled, and the pin wouldn't go into the holes without being elongated. So hopefully I can now get this so that it's a lot more accurate than it was. And I've also machined the edge ready to redo the index marks, so that'll be another of my jobs to do. And this is the back side where I've plugged in right through. They're secured in with Loctite 603. This is the index ring with it blued up on the back, and you can see where this line is here, that scribes all the way around from the pin that protrudes out that I showed earlier, and I make sure when I centre drill each position of each hole that I'm on exactly that distance out from the centre. I'm marking out the dial divisions. I've got a electronic indexing of the headstock which uses any number of divisions, and I'm actually set up for the 360 degrees for the various divisions. I've done all the major ones, I've done the minor ones, so I've done 10 degrees, 5 degrees all the way round, and then I'm just filling in the 1 degree marks. So I do 4 of those and then move on to the next one. I set a stop so that I can't go too far. I'm doing this on my little Sloan & Chase lathe, which is really very good for this purpose, even though it was made in 1936. And there's the electronic division arrangement, and there's the screen, and there's the box with the electronics in it. To show you the whole lathe. I'll just carry on now until I've got them all finished, hopefully. This is the engraving finished all the way round, fortunately without a mistake, and all the divisions are clear and legible, and all I have to do now is to figure out a way of doing the numbers, but so far that's worked well. There's just a little bit of burring to get rid of, and then that's pretty near perfect. Took me just under an hour to do the whole thing. This is the rotating base, and I finished all of the engraving of the numbers on, of the divisions on. Struggled a bit with this. I've had the cutter break on me twice while I was doing it, and getting them lined up so that they're exactly the same as before is difficult, but it can be done. And you can see I'm using a 60-degree cutter, the same as you'd use for threading high-speed steel, and the tip's a little bit exposed. On this it's quite reasonably hard cast iron, and it just breaks the tip off on the return back occasionally. But anyway, that's done now. This is how I bored out the various fittings that needed the bores to be tightened up a bit. And this is the rotary table, and I've managed to hold this securely by making a mandrel here that is turned without removing it from the lathe and held in place with a grub screw, but it's a nice tight fit on the hole that's already bored. And I just bored out 10.5mm 19mm width, so that will then get me a small collar to go in, which I haven't yet turned, but it will be coming out of this piece of stock here. So that's a nice snug fit in there, and that'll be Loctited in place. So it is possible to correct machining errors, but it's a bit tricky to get it aligned so that it's correct. Punching the numbers in is quite tricky. I showed making the little holder that sits in the tool post, and it holds that relatively square. It's not perfect, and it would be better if you milled a square hole, made a square hole, but it's just a way of getting around doing a whole lot of work, I suppose. So that I put in there, and I had to make an extension to it, so I couldn't get the hammer on the end of it. And I felt it has to be done in one hit. If you do it twice, you might end up doing it in a different place. So that I recessed the end so it fitted over the top, and a smart tap with that pop, and only one hit. I tried it with a lighter hammer, and it didn't cause enough of a indentation. Anyway, I've done both sets of numbers. On this one, it's it's not perfect. I made one mistake, and also what tends to happen, I've discovered, is that the chuck unwinds as you tap it. It loosens it and then it gradually unwinds, and you have to watch out for the changing position even though it's set up to index it, and I've indexed it at 36 divisions. So I did all the noughts first, then did the nought positions for the 90 degrees to each one, and then having done that I just filled in the intervening numbers. So it goes 0, 1, 2, 3, 4, 4, 3, 2, 1, 0, and so on. And I can take this out and give you a bit of a close-up of it. So the net effect of the engraving of the divisions is pretty near perfect and looks really good. The numbers are not as good, but I can't do any better than that. It's not an easy job, and I can see it would flummox a whole lot of people trying to do it unless you have an indexing arrangement. And the other thing is, you can quite easily forget where you are and suddenly put a number on top of a nought, which is very irritating. But anyway, that's now done, thank goodness. That was a difficult job, tedious and difficult. This is my CNC mill, which is set up to do the turning of the thread on the bar, and in the book it says 1/2 inch, and then it also says 3/4 inch for this thread. I suppose what it means is it can be between 1/2 and 3/4. Anyway, I chose to make mine 1/2 inch thread. This is the mild steel test bar that I put in, and this thread I turned with the thread going in the wrong direction. And this is machined in stainless steel in 303, and it is in the correct direction. It's a bit tougher doing it in stainless steel than in mild steel, and I found the cutter wanted to be running at about 2500 RPM, and I had to play with the feed rate. If the feed rate was too high, it snapped the tool off. And I did it in 3 passes, 1mm depth each pass, and that worked reasonably well once I'd got the speed correct. The way this works is that the commands for moving in this direction are set on the x-axis coordinates, and the a-axis takes over the y direction. That's the way that it's programmed. So if I just move, I can move this up and down the bed easily enough. The one thing I found is it needed quite a lot of oil, and it really did need to be lubricated, and the A-axis moves like so. So you have to do a combination of the axis turning and moving in this direction on the x-axis. It was surprisingly not as difficult to turn as I thought it was going to be. In fact, I did wonder if I'd be able to do it at all. As these cutters are very small, only 3mm, and after you've broken one or two, you start to think whether you're ever going to finish it. But all these are good clean up now, and yeah, I'm well pleased with that. That ended up being successful. In case anybody's interested, I did do a video on conversion of this mill, which was a manual mill, and I converted it to CNC.